Good morning guys, rescue course 4. We talk about mensuration, which include similar shape, area and volume. We will talk about the similar shape first because this we can see the recent year they all have this type of questions, and in this video all the notes will in the color of purple. Okay, so first you need to memorize all the formula for the calculation of area and volume. And this one, what we have is similar shape, similar figure. They will have the property of the ratio of their length square will equal to the ratio of their area, and the length ratio cube will equal to their volume ratio. So when the question provides you the area ratio, how can you find the volume ratio using the area ratio? First, you use the area ratio to find the length ratio first, and then cube it. You will have the volume ratio. You cannot directly square this to find the volume, okay? Cannot. So you need to find the length first and then cube the length ratio to find the volume ratio. Okay, and other formula for the calculation of volume and surface area. So I need you to remember this four, especially this one, very special one for the cone, okay? And then for sector, you also need to memorize this, okay? So very high possibility we'll have this four type of figure. So 2012 questions is a variation question in part A. They mix these two topics together, and first you need to list out the two equations for variation, so equation 1, equation 2. Read the question yourself and try to do it. And then after you solve this, you have K1 and K2, you have the equation, and then you put in A equals to 13, okay? A equals to 13, and then you will have the total cost. Okay, so question B, it tells you that a larger can which is similar. It means that they have the ratio property, okay? Ratio property. And then the volume of the larger tank is 8 times. Everyone, here is the volume ratio, okay? Volume ratio. Okay, that the can described in A. We'll find the cost of printing. Now it's finding the cost of printing. The printing depends on the area, the surface area. So what we need to find actually is the area, not the volume. But the ratio given is in volume. So the first step, what we need to do is change the volume ratio first back to the length ratio, and then square them to have the area ratio. Or you can directly do it in one equation, 1/8, and then to the root, cube root, and then square it. Both methods, okay? I think this clearly show how the process change. And then next one, you have the area ratio. You will know the largest can have 13 times 4, 52 meters square as the surface area. Now you put the surface area into the formula you found to find the cost, because the question is asking the cost, not just ask you to find out the surface area. So you need to put back into the equation. Okay, so you have the total cost. 2013's paper, this year's paper, I suggest you to do it by yourself first. So we read the question. Two identical solar metal right circular cylinders of base radius RCM. Those melted and recast question, as I say, use the concept of volume because their volume stay the same. The surface area will change and the length will change, but the volume always stay the same. And then it goes into 27 smaller circular cylinders of base radius R and height 10 cm. Okay, so you can draw it out if you feel the wordings here is very complicated to you. So you draw it out, it will be very clear. You don't have the height of the larger cylinders, and then for the small one you have it all, okay? And the question, another information here is the base area of the largest cylinder is 9 times of the smaller one. So the base area, it means here to here should be 1 to 9, okay? So now if ask you to find the ratio of their radius. So radius basically is length. Use the area ratio to find the length, very easy. So we have the area ratio, we find the length ratio, so it's 1 to 3. Very easy, two marks here. And then find the height of the larger cylinder. Can we directly use the length ratio we find to find the height? because we know the length ratio is 1 to 3, right? And then the smaller one have the height 10. Can we just 10 times 3 equals to 30? So for the largest one, the height should be 30. Can we do that? So first, you can see, if it's that easy, will it give 3 marks to you? So it's not that easy. Why? Why? Because it only tells you the base area is 9 times of the smaller one. It doesn't mean the whole shape here are similar. It doesn't mean they are similar. It just tells you that the base area now they have a ratio. It doesn't mean that the whole figure they are similar. Okay? Keep in mind that that's different. Okay, so we use the volume stay the same concept. So volume stay the same. The smaller one, we have 2 identical, right? And then the base area, r square pi times the height. We don't know the height, we are finding the height, so you need to let that first. And then the smaller one, we have 27 base area times the height. And then what do you need to do here is first cancel the pi, and then move all the thing to one side. And then the numbers here, this one, we have 2 unknown here. Can we solve it? Actually, we can because we know the ratio. Okay, this is actually this one, right, from part A. So r over capital R should be 1 over 3. So what we have is put in 1 over 3. 1 over 3 square times the number here. So h equals to 15. It's not 30. If you directly use this one times 3, it equals to 30, right? So it's not correct. It means that they are not similar. Actually, they are not similar. Okay, so question B asks if they are similar. Okay, if they are similar. So if it is similar, it won't ask this question, right? It means that when you're doing this one, you cannot find the height by the theory of similar because they are not similar. Okay. Okay, so if it is similar, all the length will be in the same ratio. So we just need to check all the length we have, are they in the same ratio? Now we have the radius 1 to 3. We find the height 10 to 15. 2 is 2 to 3, so it's not 1 to 3. We are not agree with it.